Welcome back to another integral a day. Today I've got another problem for us to solve. I'm thinking that this will be the last reverse power rule problem we're going to do with integrals before we move on tomorrow to sort of a new area that includes these, as most questions do, but we'll be doing things a little bit more complicated, I guess you could say. But yeah, today, with today's, I wanted to change it up a little bit and still give us something a little bit different. So we have this function m with respect to p, and I'm going to put in some fractions here. And what these do is later down the track, we're going to need to apply a fraction rule that comes up, that it's really handy to know. And these fraction rules just become second nature after practicing them enough, really. So yeah, I'm going to show that to you. I'm just going to pick a new color for our working. So as we can see, we've got three terms here. We're just going to start with the first one. Let's write this out as if it is an integral. Integral 4p. Try to write this a bit quicker at the expense of how tidy it is, because it's just above. It's exactly, no, getting it wrong though. Delete. All right, 1/5. Yeah, dot dp. Do not forget the dot dp or the dot whatever it's respect to. I find it way too easy to forget. But all right, let's take this first term. So here we're just going to do what we usually do. So it's the same thing. So it's 4. Actually, something I don't think I've said in the past few videos, but whenever you, with this integer or whatever number's out the front, we can just literally, what we usually do is put it outside the integral sign. It's like putting it outside the gate, so we can, if we see this integral sign as a bit of a gate, and that gate is separating what we focus on this side, what we're actually working on, and what we can work on later. That would be our gate. Like, pretty much we're putting 4 or the number outside the gate. We're just saying, look, we're just going to work with p 1/2. We're going to integrate that. That's with respect, this is our p term. We're integrating that. So, and we're just integrating this, and we'll bring this back in later. So that will now equal I need to think for a second. I think we can do this. Let me know if this would be wrong in the comments, but I'm going to write it like this. p 1/2 plus 1. So this part definitely is right. You add 1. I'm just wondering whether we can still write the integral sign there with the plus 1, because it's already integrated, I would think. Yeah, and then as we said yesterday, we just literally add 1 whole, 1 to whatever's in the exponent, and then bring that value below. So this is what this will look like. Now I'm going to bring the equal sign back here, and so since we're adding 1 whole to 1/2, we're pretty much filling up. So 2/2 is equal to 1 whole, and then we're just adding 1 to the top. So we've actually got 4. No, I don't feel right writing that integral sign there. I'm going to Google that tonight. For now, I'm just going to write 4 times P. So we've brought it inside the gate, we're now focusing on it. And that now turns into 3 over 2. All over 3 over 2. This is where our fraction rule comes in now. So here we have usually what we'd like is just one nice whole number underneath our fraction here, as we don't usually like a fraction being like in the denominator. So what we're going to do is apply this rule that pretty much says, I'm going to write it over here. It says, I've got it written down in the formal way just beside me here. So I thought you'll want to see that. A, this is that really big one, is equal to A times C over B. So what we're saying, we currently have this here, A over B over C. That's what we've got here. This is our A term, and then this is our A term, and we've got B over C. What we're saying is we can just bring C on top and multiply it by our A, and leave B on the bottom. So now to sort of match these a bit, this can now equal 4 times by 2 P 3 over 2 over 3. And now that, just simplifying that a bit further, we've got 8. P is 4 times 2 is 8. Over 3. And that's our first term, or at least what I believe to be our first term. And now here we've got a negative number out the front here, which really doesn't mean all too much, it's just different. But this is just what we usually work with, so we'll be able to do this. I'm just going to highlight our terms. So this was our first one. Usually wouldn't set out your working like this. I just did it here so I could show this easily. I'm going to continue to write it this way though. So we've got negative 2 P squared dot dP is equal to negative 2 times by, now we add 1 to the top, so it's P 3 over 3. And that then equals, or negative 2 on 3 P cubed. There we are. And now I'm just going to highlight that. Second. And our final term, P 1 over 5, will, integrating it, dot dP will equal, well, we just add 1 again. So 1 over 5 plus 1 whole, which I'm sure you could all guess with how we did this before and how that all worked out. When we just add 1 to a fraction with the 1 on top, we get something very similar. We get P 6 on 5 over 6 on 5. And then further, like just rearranging this, we have this, and we can say this is equal to just bringing 5 on top. P all over 6. That there is our third term. Just for the sake of consistency, I'll do that. All right, and now we can just put it all together. Oh, oh no, we have a negative there. I was afraid I didn't include the negative for a second. Yes, I'm running off of 3 hours of sleep again, which isn't good for my body. So I do make mistakes when I'm this tired, and a lot of them. So M, it's a capital M, lowercase p, is equal to the first term, so 8. We can just write it as 8 over 3. Just like bring the, bring it out as a fraction with just the numbers out front. P 3 on 2. Now we've got a minus 2 on 3 P cubed. Cubed, or yeah, cubed. And then plus, since there's no minus there, it's a plus. We've got 5 on 6 P 6 on 5. Here we have that. So yeah, let me know in the comments if you got a different answer. I'm gonna go check this on Symbolab after. I should really check it beforehand, but I know I'm pretty sure that's right. If it's wrong, I won't be uploading this video. I'll upload a new one. Yeah, well, I hope you have a good day, and yeah, I'll catch you all here tomorrow for a brand new integral question that's a bit different to how we've been doing it. Yeah, see you then.